Hello everyone, welcome back to my channel. Today let's go over another medium level question that I was able to resolve on my own 5 minutes ago after about 1 year. So yeah, I'm really happy that I was able to do it without any assistance and solve it completely on my own again. So let me show you how I did it. Basically, you just follow this formula and how many rows in the ith row plus how many ones in the jth column minus how many zeros in the ith row minus how many zeros in the jth column. Okay, so it seems pretty straightforward. So let's go ahead and, basically I'm going to show you how I did it. Basically, I just kept track of all the rows. So for G and grid, the current row, we're just going to pen G. And then obviously we need the row sum. And I'm just going to do this. And we're going to do columns as well. And then also column sum. Okay, so, and then to get the columns, this is my way of doing it. There's probably a better way, but basically less than length of grid 0 for J in range, length grid of I or grid. Let's call this current column. We're just going to append grid J of I and then move the pointer forward. Let's just print, first columns.append cur call.copy, and let's verify. Cool. So 0 1 0 1 0 0 and then 1 1 1. That's fine. Cool. So now basically let's create a copy of this matrix and set everything to 0. So let's call this answer, and let's go over the grid. And for, let's say, num in G, then let's call this, just call this A for simplicity. We're just going to fill it with zeros. So the whole thing filled with zeros, just make a copy of it. Because you know this has to be 0 or 1. So answer.append a.copy. And then we have to follow this. So basically for I in range length grid, because answer is the same size, right? I just made a copy. Range length grid of I. So let's call this now is just going to be one's row. And the reason I made the column sum and the row sum, as you'll see, is because row sum.append sum of G, because we want to do this more efficiently than getting the count of every single row and column, which is going to be slow. So let's say column sum.append sum of cur column. Basically, if we do it the naive way, you'll see. So basically just rows I dot count of 1 plus columns of J dot count 1 minus, I'm just following this right here, zeros row is just rows I dot count 0 minus columns of J dot count of 0, and then you just fill whatever this value is. So answer ij is equal to now, and then at the end you can just return answer. Okay, so this technically works, but this is going to be really slow, and this can be optimized. And so if you notice that these are only 0 and 1, you can see a pattern, which is that you get time limit exceeded. The total number of ones is just going to be the sum, because anything else has to be a 0, right? So if the sum of this is 2, then that means there are 2 ones in it, because the whole thing can only be at most 3, because there are only zeros and ones. Everything else has to be 0, as I just said. So we can just say rs of I, which is just the sum of that row plus, and we're going to do the same thing with the columns. So cs of j, same thing. There's still zeros and ones throughout the whole matrix because it's a binary grid. And then for 0, basically you take the length minus the sum, because that's how many zeros. Anything else has to be a 1, right? So in that case, we can just do length of, what was it? Row. So length of grid, because the row is the width, minus rs of I, so the sum of that, and then also this is just going to be length of grid of 0 minus cs of j. Okay, so let's run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to resolve this question on my own without any assistance. So yeah, I'm pretty proud of that. That's it for this video. Thank you for watching and stay tuned for more.